Good morning, sir.
Yeah. So we'll start with time translation or what happened yesterday. We discussed about translation and rotation, space translation and rotation. Let me share my screen. So is it visible to everybody?
Yes, sir.
Okay, good. Uh, just for check, is the video also visible to you? My notebook and
Yes, sir.
okay, good. All right. So then we'll start. So yesterday we discussed about what happens when we want to have space translation or uh, a rotation of the system. Then we found that for translation, it is the momentum operator, which is a generator, and for rotation, it is the angular momentum. So linear momentum and angular momentum are the generators. Today we'll talk about time translation. So time translation is nothing but suppose we did some measurement right now, and maybe after 10 seconds or 20 seconds or 10 minutes. So at t equal to 0, you have a wave function. And then what happens at after time t? So that is, in one sense, you can say evolution operator or time evolution operator. Huh? So, as it is mentioned here, psi 0, the 0 denotes at t equal to 0, and psi t is basically the wave function at time t. Uh, so, it is generally represented by an unitary operator, time evolution operator, represented as ut, uh, which basically operating on psi 0 will give rise to psi t. So if we operate ut on psi 0, we'll get psi t, uh, where ut has the form e to the power minus I h t by h cross, where h is your Hamiltonian. In general, we can write psi t 0 like this. So bracket notation for quantum 2 mostly, you have to little bit familiarize yourself with the bracket notation. uh, Maybe earlier in BSc or in the quantum 1 part of it, the integration or the wave function as e to the power ikx format will be okay, but later on I think that bracket notation is very much important for representation, and we should know what state vector actually means. So psi t as psi t cat would be equal to u t t 0 uh, going to psi t 0. So this is um, like, if it is 0, then it is t 0 is equal to 0. If it is uh, sometime t 0, then we just use this kind of format. Should not be an issue. We just have to remember that the operator is of the form e to the power I h t by h cross, where h is the Hamiltonian. Now, we also know that the state vector must be conserved. That means symmetry operations, this kind of operations should not change uh, the system. So psi t bracket must be equal to psi t zero bracket. Requires the unitary of the time evolution operator. Another important property of the time evolution operator is that the time evolution of a system from T0 to T2 is equivalent to a time evolution from T0 to T1 and T1 to T2. So it's kind of cascading. You know? So if you want to go from 0 to 5 second and then 5 second to 10 second, it is equivalent in going from 0 to 10 second. So the basic idea is what happens if we have a wave function, let's say right now, which is I take t equal to 0, then how exactly I'll have the wave function at some other time t. And for that, I need to operate with an operator, and that operator is time evolution operator, and that is of the form e to the power minus I h t by h cross. Is this clear? Now, if we go from T0 plus eta, T0 plus eta, then it will be U T0 plus eta to T0 psi T0. So, we need to, like we did, let me remind you again, we let us come back to here. So, here, rotation. How was it? E to the power this form. There is another generator form also. Let me come back to the generator form. Yeah. So Rz is I cap minus I phi z Lz by H cross. So where Lz is the generator. So we also need to find out for the time evolution operator. For the time evolution operator, we also need to find out similar kind where u cap eta, where eta is the translation in time, will be equal to some identity matrix minus I eta k cap, where k cap will be the generator. So where the generator of time translation k cap is Hermitian. Clearly, the unit of k cap is in time inverse. It has to, because if eta is time, then k cap has to be time inverse. Otherwise, it will not be. You can see it here. Uh, this one psi t0 plus eta, so eta has to be t0 plus eta means eta has to have the dimension of time. So if eta has to be the dimension of time, so for this quantity to be dimensionless, we have to k has to be time inverse, huh? So k, clearly the unit of k is in time inverse. The classical, from classical mechanics, uh, we already have the Hamiltonian is the generator of time translation. It is known from classical mechanics that Hamiltonian gives the time translation. We just borrow that idea that k cap is equal to h cap by h cross. See, in all these three, a question might arise: how exactly I am knowing that in the first case it is momentum, second case it is angular momentum, and in the third case I am telling it is Hamiltonian. No, we only know what the property of the operator should be, and then a quick guess. Uh, we are telling that from our knowledge of classical mechanics, let us use either linear momentum in case of space translation, or angular momentum in case of rotation, and Hamiltonian in case of time translation, as a trial error basis. Because if that satisfies all the properties, required properties of the time evolution operator, then that is good enough to use. So in that sense, we are just borrowing that idea, and we are telling that the generator k cap is h Hamiltonian by h cross. So using that uh, formula, k cap is equal to h cap by h cross in this one over here. So we get u eta is equal to I minus I eta h cap by h cross. You can check that a time translation operator for infinitesimal time translation is unitary. So if u is of this form, then you can just check that u eta dag into u eta is equal to I identity. It is very simple, right? What will be u eta dag? What will be u eta dag? All of you can evaluate, right? Uh, so what we need over here is so what is given is u eta u cap eta is equal to I cap minus I eta h cap by h cross. So what will be my u eta dag? That will be I dag plus I eta h cap dag by h cross, right? Is it clear? Visible?
Yes, sir.
Yes, sir.
Yeah. So then, what is identity? If we take that, it will be identity only, right? Plus I eta. Now Hamiltonian is Hermitian, right? So it will be simply h cap by h cross. Now, can you evaluate what will be u eta dag into u eta? Just multiplication of this with this one. What exactly we are getting? Can somebody evaluate? Right? Now I it will be I square, that will be again I. Then it will be what? I into this one. So that will be minus I eta h cap by h cross. Another will be plus I eta h cap by h cross. And then it will be minus I into I. That will be minus I square. That will be plus. Then if we multiply, it will be eta square h square by h cross square, right? But eta square is very small. It's a very small time translation. So we can possibly neglect this one, and these two cancel with each other. So we are left with I. So that means u eta dag into u eta is equal to identity. Is this clear?
Yes, sir.
Yeah. So this which is basically over here. Similarly, if we are taking eta 1 plus eta 2, you can simply, by using this one, you can simply express that it will be product of u eta 1 and then u eta 2. This is nothing but telling that if I have a wave function right now at t equal to 0, and I want to go from t equal to 0 to, let's say, t equal to t1, and then from t1 to t2, so then I can just operate it with some, cascading kind of stuff. So once I operate with first unitary operator, and then again for t1 to t2, I'll operate with it again. So uh, this is the form of unitary of the time translation operator that we will be using, where Hamiltonian is the generator. Now, similar to what we have done in case of rotation as well, a finite time translation, this is very important, a finite time translation eta can now be constructed by dividing the interval eta into large number capital N of infinitesimally small time intervals, which is eta by n. Because if n goes to infinity, then eta by n will be very, very small, right? And in the first argument, we are telling that the time translation is for very small interval of time. So then the unitary operator, time translation operator, would be limit n tending to infinity, I minus I eta h by n into h, because now instead of writing eta, we are writing eta by n. So this will give rise to, this will be equal to exponential minus I eta h cap by h cross. So this will also, in quantum 1 probably you have done that the time evolution, when you separate the wave function, this time dependent and time independent part. Do you remember what was the time dependent part? Anybody? मेरा सवाल समझ में आ रहा है? जब आप लोगों ने हाइड्रोजन एटम सॉल्व किया या फिर टाइम डिपेंडेंट से टाइम इंडिपेंडेंट श्रोडिंजर इक्वेशन डिराइव किया, तो उसमें टाइम डिपेंडेंट पार्ट को सेपरेट किया था, राइट?
Yes, sir.
तो टाइम डिपेंडेंट पार्ट का फॉर्म क्या था, वो कैसे दिख रहा था? इट वाज e to the power minus I omega t, right? It was e to the power minus I omega t, isn't it?
Yes, sir.
Yes, so you can see that it is coming the same form, right? E to the power minus I. Now Hamiltonian is nothing but energy, right? So
Yes.
IET by h cross, where eta is time. Eta is time
Time.
only. So it will be I, IET by h cross, which is nothing but minus I omega t. So you already have done it actually, but how exactly it came as a time evolution? So here we are getting, so basically the unitary operator should be of the form I minus I cap minus I eta h cap by nh to the power n. So if we take n tending to infinity, this will basically reduce to this exponential form, which is obvious, which we have already used, and all the results are coming good, right? So which is, it also says here, which is identical to the time evolution operator, equation 1.62 with t minus t0 is equal to eta. The expectation value of an observable A at any instant of time t for the general state psi t of the system. Expectation value कैसे निकालते हैं? We just take the product, right? Psi t A psi t, right? Now, what is if we want to express psi t in terms of psi 0 or psi t0, we just have to use u t t0 psi t, right? And if we take a DAG, then it will come u t t0 DAG. So it will come this form. If the initial state t equal to 0 is an eigenstate of the Hamiltonian, say ei, then what we will get is, if it is an eigenstate means it will give you energy, right? So instead of writing psi t0, we will write state, the initial state e. So eit and eit. So that will basically be e to the power I eit by h cross. As I was telling, that it is nothing but e exponential minus I H for E and eta for T, IET by H cross. That is what it is used here. That the unitary operator would be e to the power I minus I e t by h cross, and if it is u dag, then the minus I will become I. So then it will be e to the power minus I e I t by h cross a e to the power minus e I t by h cross. So this will just cancel, or this will be 1. So it will be equal to e I a e I. Is this clear to everybody?
So please once more.
Yes. So it is clear up to this point, right, that the unitary operator is of the form
Yes, sir.
exponential minus I eta t I eta h cap by h cross. If I want to have in terms of energy, it will be what? Exponential minus I e t by h cross, right? Now, what will be u dag? U dag will be just I going to minus I, or minus I becoming I, right? So your u dag will be what? E to the power I e I t by h cross here. Let me scribble a little bit, so then it will be clear. Over here. So if when we use this part here, because we have to use u t t0 dag, right? So the dag operator will basically, the adjoint operator will basically take from minus I become I. So it will be e to the power I e t by h cross, and normal u will become e to the power I e t by h cross. Is it clear?
Yes, sir.
Yeah. So then, as you can see, the expectation value is not really changing. It's the same. So the expectation value remains constant with time. However, if the initial state is not an eigenstate of H, we can write the initial state psi 0 as a superposition of the eigenstates, right? So अगर वो आइगन स्टेट है ऑलरेडी, जो स्टेट हम लिख रहे हैं, इफ साई जो जिस स्टेट के बारे में बात कर रहे हैं, इफ साई जीरो इज ऑलरेडी आइगन स्टेट, so then it is obvious that we will not get any change in the expectation value. But if it is not an eigenstate, then we know that we can express it in terms of linear combination of all eigenstates. If psi 0 is not an eigenstate, then it can be expressed as a superposition of eigenstates of the Hamiltonian. This is very much clear, right? This equation, if psi 0 is not an eigenstate, then it can be expressed as a linear combination of all eigenstates. And if that is so, instead of psi 0, what you will write? We will write this formula summation over I ci ei cat. So that we will substitute here. So what exactly you are getting is ci e to the power minus iet by h cross. So expectation of value of a at any time t will again, as you can see, this is simple mathematics. There is nothing more. Only thing is, instead of psi 0, we are now writing ci and cj, just to separate it. So you get this coefficient summation over I summation over j ci cj. Then is going from state I state j. So ej a ei e to the power minus I omega ij t by h cross. So what is omega ij? The expectation value has an oscillatory term with angular frequency omega ij. So the conclusion is, if the system is in the eigenstate of the Hamiltonian, then the expectation value remains constant. It does not change. If the system is not in the eigenstate of the Hamiltonian, then the expectation value will have an oscillatory term e to the power minus I omega ijt by h cross. Okay? Is it clear?
Yes, sir.
All right. Next, we'll talk about conservation laws. So, are you familiar with this equation? Uh, it's
Lagrange's equation.
Euler-Lagrange equation of motion.
Lagrange.
This is this is might have been
Lagrange's
covered.
equation.
Yes, Lagrange's equation of motion. Here it is in EL equation. That is Euler-Lagrange equation. Okay, EULER, Euler-Lagrange equation of motion. So that is d by dt del L by del Qi dot minus del L by del Qi is equal to 0, where L is a function of Qi dot and T. It's a Lagrangian, right? So T minus V form, kinetic energy minus potential energy. All of you remember that, right? From classical mechanics. So when L does not contain Qi, and Qi is a cyclic coordinate, then del L by del Qi is equal to 0. And d by dt of del L by del Qi dot is equal to 0 implies Pi is equal to constant. This is very much clear that from this equation, if the second part, if del L by del Qi is 0, that means the Lagrangian does not have an explicit Qi dependence, then the second term is 0. This implies the first term will become 0 because the right hand side is 0, right? So if D, that is what it is telling. When L does not contain Qi, then del L by del Qi will be equal to 0. If del L by del Qi is equal to 0, that means d by dt of del L by del Qi dot will also become 0. If this is 0, when the derivative, explicit derivative with respect to time is 0, that means del L by del Qi dot will be a constant, right? Constant of time. So that means, what is that? Del L by del Qi dot, that is Pi, right? So Pi will become constant. If L is not a function of Qi, this also means that the L is invariant under an infinitesimal translation given by Qi is equal to Qi plus delta Qi. Is this part clear to all of you? This is from classical mechanics. What we have studied, you might have studied already. So we will be using similar formulation in quantum mechanics now. Anybody any questions up to this point? No? No questions? Okay. So if L does not depend on Qi, that means that L is invariant under an infinitesimal translation. This is very important from our argument perspective, but in the symmetry operations, what we have discussed. So the invariance of L under translation of coordinate Qi implies that the canonical momentum Pi corresponds to the generalized coordinate Qi is a constant of motion. Is a constant of motion. अगर L explicitly Qi के ऊपर जनरलाइज्ड कोऑर्डिनेट के ऊपर डिपेंडेंट नहीं है, तो जनरलाइज्ड मोमेंटम या कैनोनिकल मोमेंटम जो है वो कांस्टेंट होगा. So if we similarly the Hamiltonian, in case of Hamiltonian formulation, might have seen if del H by del Qi is equal to 0, then the momentum Pj is a constant of motion. So these are the ideas we are borrowing from our classical mechanics discussions. So whenever the Lagrangian or the Hamiltonian of a system are invariant under a translation or have a symmetry corresponding to translation, there is a conserved quantity which is momentum. So this is very much clear from this Euler-Lagrange equation of motion. So if now, let's say for space and time translation and rotation, you describe it by an unitary operator of infinitesimal translation or rotation, epsilon, is basically given by the operator S and it is generated by an operator K, then K has to be Hermitian. So K, the generator of transformation, is Hermitian in anticipation of this symmetry operation. So what we will have, that if this operator is invariant under space translation or rotation, then what we will have, the corresponding generalized momentum. The corresponding generalized momentum K will be a constant of time, right? K will be a constant of time. Let us discuss a little bit about how exactly it is coming. Let me explain that. So S operating on psi will give rise to psi S. Now here we are actually combining both translation and rotation. This is just symmetry operation. So that's why it is S. Any translation is a symmetry operation and rotation is also a symmetry operation. So if we take in general and symmetry operation S, where the change is epsilon, is a very small change. It could be space translation or it could be small angle rotation. So then S epsilon operating on psi will give rise to the transformed state, which is psi S. Now, if this is the case, we can simply write that if you take a dag, then psi S dag will give rise to S. Let us now say that the invariance of the system under symmetry operation S, if the system is invariant under the symmetry operation, then psi Hamiltonian psi will basically give rise to what? Psi S Hamiltonian psi S, because this is the transformed, the right one is the transformed one and the left one is the initial one. So if it is invariant under symmetry, then if we take the Hamiltonian expectation of Hamiltonian in the transformed state, that must be equal to the expectation of the Hamiltonian in the initial state. And this psi s, what exactly we are writing? Psi s is equal to s psi, and if we take the dag, then it will be psi s dag. So substituting that, what exactly we are getting? That's s dag h psi. So psi h psi initial expectation must be equal to the transformed expectation, which is psi s h psi. And if we rewrite this right hand side part, so psi s is basically your s psi, and psi s cat is equal to s psi cat, and psi s bra is basically equal to psi s dag bra, right? So if we substitute that over here, then we will get psi s dag h psi hs psi. So that means this h must be equal to s dag hs. So that is what it is written here. That which gives s dag hs is equal to h. Now, if s dag hs is equal to h, if you multiply on the left s, uh, so let me tell that again. If your s dag h s is equal to h, so if you multiply s dag h s will be equal to s h. I'm left multiplying s, so s dag will be unitary. So this implies uh, identity h s will be equal to sh. This implies hs. If I multiplying I, that will not change the matrix, right? So hs is equal to sh, or sh minus hs is equal to 0. This implies sh commutator will be equal to 0. Is this part clear?
Yes, sir.
So that's what it is written here. sh commutator bracket will be equal to 0. Clear? This is what we have discussed, right? How exactly from S dag HS is equal to H, it has become SH is equal to 0. Now, let us try to evaluate. So, S, the operator S, we said that operator S should be of the form I minus I cap minus I epsilon K cap, where K cap is nothing but the generator of the symmetry operation. So S is the operator and K cap is the generator of this, whether it is translation or rotation or time translation, K cap will be the generator. So in that case, if we try to find out what is the expectation value, what is the expectation value psi h psi. So expectation value of Hamiltonian, and what we will do, what we will do, we have to substitute, right? So I cap plus I epsilon K cap H I minus, because here we have seen H cap is equal to S dag H S. So we are substituting that. We are trying to find out psi H psi. So instead of H, now we will write S dag H S. S dag H S. And what is S? S is I minus I epsilon K, and S dag is I minus I plus I epsilon K. So this is S dag, this is H, and this is S. So if you multiply, if you can see, this one, let me write it down, so then it would be clear a little bit. So what we have is psi H psi, and what we will write is equal to psi S dag H S psi, right? And this will be, what is S dag? S dag is I cap plus I epsilon K
K
cap
cap.
H, and then I minus I epsilon K cap psi, right?
Yes, sir.
Now, since there is identity, it will be psi H psi. One will come, right? If I am multiplying, then what will come? Plus I epsilon is a number. I epsilon is just a number. So I will take I epsilon outside. So it will be psi, and then here it will be kh minus hk. From this term, it will be kh minus hk, right? Is this clear? The last term would be, there is another term which is plus I into minus I, which is 1. So it will be epsilon square, then k square, epsilon square, k square, right? Uh, Let me write down here. Then it will be psi over here and psi over here. This kind of term will come, right? Is it clear? Now epsilon is very small, so we can drop this one. Epsilon square we can drop. So what we will have? So higher order terms we can drop. So what we will have? So this will become now will be equal to psi h psi plus I epsilon kh minus hk. It is nothing but the commutator, right?
0.
No, it is, if it is invariant. That's what I am telling. We'll come to that. It will be. It has to become 0 because the expectation value of Hamiltonian will not change, right? The expectation value. That is what it is telling you. That is what it is telling you over here, that From this we get that the Hamiltonian H of the system to be invariant under the symmetry operation. अगर Hamiltonian को क्या रहना है, invariant रहना है under the symmetry operation, which it remains, then this second term has to become zero. The second term has, अगर second term zero नहीं है तो ये इसके साथ equal नहीं है ना? So that is why the commutator, expectation of the commutator has to become equal to zero. KH commutation should be equal to zero. ये समझ में आ रहा है ये कैसे हुआ?
Yes, sir.
Is it clear up to equation 1.79?
Yes, sir.
Okay.
Yes, sir.
Now, all of you remember what is Arnfest theorem, right? Arnfest theorem क्या बोलता है? Arnfest theorem is basically is a bridge between classical and quantum mechanics, right? अगर कोई क्वांटिटी है उसका टाइम इवोल्यूशन डी के बाई डी टी वो कैसे आता है? इट इन्वॉल्व्स के एच कम्यूटेटर, राइट? क्वांटम 1 में पढ़ा है नहीं ये?
Yes.
आर्नफेस्ट थ्योरम पढ़ाया होगा ना? So dk by dt, d expectation of k by dt will involve kh commutator. Since we are getting from symmetry operation that for Hamiltonian to be invariant under the symmetry operation, kh commutator expectation has to be 0. So that is why your dk by dt, d expectation of k by dt has to be equal to 0. So then you can see that expectation value of k is a constant of time. It will not change with time. That is what it is telling you. If the Hamiltonian of a physical system is unchanged under a translation or rotation of the symmetry of the system defined by an operator S, S is the symmetry operation and generator of the symmetry operation is a constant of motion. जो भी generator होगा वो एक constant of motion होगा. अगर किसी भी symmetry operation में Hamiltonian change नहीं हो रहा है, if the Hamiltonian of the physical system is remaining unchanged, तो उस symmetry operation का जो भी generator होगा, whatever, पर मान लो I mean, if you think कि translation for translation it is linear momentum, for rotation it is angular momentum. So then those generators have to be a constant of time. They will not change with time. And similarly for time translation, it will be the energy or the Hamiltonian itself will be a constant of motion. So it will not change over time. So dk by dt, d expectation k by dt will become equal to 0. And you can verify actually this for any generator, the commutator bracket for the generator with Hamiltonian must be equal to 0. Commutator with Hamiltonian must be equal to 0. That you can verify. Okay. ये बात समझ में आ रहा है सबको?
Yes, sir.
तो क्या हुआ? Just in couple of lines, if we try to summarize, we came to know about symmetry operations. और symmetry operations के लिए जो operator होता है वो उसमें एक generator होता है. और हमने देखा है कि symmetry operation में expectation value अगर change नहीं हो रहा है of the Hamiltonian of the energy, तो उस केस में जो generator है उसका वो it should be a constant of motion. और वो कैसे मैथमेटिकली कैसे उसको चेक करना है कि वो जनरेटर का हैमिल्टोनियन के साथ जो ब्रैकेट जो कम्यूटेटर ब्रैकेट होगा, सो के एच के अगर जनरेटर है तो पहले हमको चेक करना है कि के एच इज कम्यूटेटर, दैट मीन्स के एच माइनस एच के वो जीरो हो रहा है क्या? अगर वो जीरो हो रहा है then that generator is a constant of motion. So that is kind of conservation principle. अगर ट्रांसलेशन स्पेस ट्रांसलेशन के लिए मोमेंटम जनरेटर है और मोमेंटम हैमिल्टनियन के साथ कम्यूट कर रहा है, सो देन विल हैव मोमेंटम टू बी कंजर्व. सिमिलरली अगर रोटेशन हो रहा है और रोटेशन के लिए जनरेटर अगर एंगुलर मोमेंटम है और एंगुलर मोमेंटम हैमिल्टनियन के साथ अगर कम्यूट कर रहा है, देन हैमिल्टन एंगुलर मोमेंटम विल बी a constant of motion. Similarly, energy के लिए Hamiltonian will commute with Hamiltonian itself. So that's why energy will also be a constant of motion for time translation. So symmetry and conservation principles. Where तो ऐसा नहीं है कि एनर्जी कंजर्व होना है, मोमेंटम कंजर्व होना है. So you have to just check whether the Hamiltonian is commuting with the generator or not. जहाँ पे वो commute नहीं करेगा, वहाँ पे वो generator conserve नहीं होगा. अगर energy कुछ जगह energy conserve नहीं हो रहा है, then we can check कि जो operation हो रहा है, जो symmetry operation हम operate कर रहे हैं, वो उसका जो generator है, वो Hamiltonian के साथ commute नहीं कर रहा होगा. Okay? Next is symmetry and degeneracy. Degeneracy का मतलब है कि more than one state will satisfy the same condition. ठीक है, तो अगर symmetry operation हम ले रहे हैं S और उसके साथ we can generate like it says, we see that the symmetry operation gives us SH commutator. Now if EI is an eigenstate of H, then an eigenvalue EI, then SEI is also an eigenstate. मतलब क्या है? इसका मतलब क्या है कि अगर हैमिल्टोनियन का एक आइगेनस्टेट है EI और हम एक सिमेट्री ऑपरेशन ले रहे हैं S, तो SEI भी एक आइगेनस्टेट होगा. सो दैट विल आल्सो, मान लो हम कोई भी ट्रांसलेशन सिमेट्री ऑपरेशन कर रहे हैं या रोटेशन सिमेट्री ऑपरेशन कर रहे हैं, तो जो भी ऑपरेटर हम यूज कर रहे हैं उसको अगर हम उस आइगन स्टेट के ऊपर ऑपरेट करेंगे, जो नया स्टेट हमको मिलेगा, दैट न्यू स्टेट विल आल्सो बी एन आइगन स्टेट. सो देन using that concept, so then we will have many eigenstates which will basically satisfy that same condition, right? So that is why, so in general there will be more than one states which will satisfy this kind of symmetry operations and give rise to degeneracy. Clear? Okay, so then I will possibly take a couple of minutes break and then we'll move over to the next part. Here there is summary of this unit and yeah, so basically what we discussed: symmetry operation, space translation, rotation, time translation, then conservation laws. Okay, there are few solved questions as well. You can try. All right.
Yes, sir.
Yeah. So
Okay.
couple of minutes break, then we'll start with the next part. Symmetry in quantum mechanics. Basically, we'll talk about parity and time reversal. Any question up to this point?
सर एक्चुअली कल का जो क्लास आप सुबह किए थे तो मुझे नहीं पता था, मैंने नहीं किया था कि आप पढ़ाया था, थोड़ा पता नहीं, ब्रीफली थोड़ा शॉर्ट में कहे थे तो अच्छा था।
बेसिकली जो समरी है, go back to the summary. So हमने स्टार्ट किया कि सिमेट्री ऑपरेशंस क्या है. तो सिमेट्री ऑपरेशंस आर दोज ऑपरेशंस व्हिच विल लीव द सिस्टम इनवेरिएंट. तो सिस्टम चेंज नहीं होगा. तो सिमेट्री ऑपरेशंस अगर हम नॉर्मल जो ऑपरेशंस कर रहे हैं, स्पेस ट्रांसलेशन कर रहे हैं या रोटेशन कर रहे हैं या टाइम ट्रांसलेशन कर रहे हैं, तो उसमें वी फॉर्मुलेटेड कि दैट विल बी एक्सप्रेस्ड बाय एन ऑपरेटर. वो ऑपरेटर का फॉर्म क्या होगा? जैसे ट्रांसलेशन के लिए टी विल बी इक्वल टू आई कैप माइनस आई एप्सिलॉन पी बाय एच क्रॉस. ठीक है. So similarly for rotation it will be the operator will be I minus I cap minus I phi z, which is the angle, then Lz, the z component of angular momentum by h cross. हाँ. तो सिमिलरली फॉर टाइम जैसे मैंने आज बोला, सो उसके लिए क्या होगा? बेसिकली e to the operator would be e to the power minus I h t by h cross. सो ये फॉर्म ऑफ द ऑपरेटर हमने निकाला उस डिस्कशन में कि वो अगर मान लो एक सिस्टम भुवनेश्वर में है, उसको हम शिफ्ट कर रहे हैं कैलकाटा को. ठीक है. सो वी आर मूविंग इन स्टेप्स. लेट्स से स्मॉल अमाउंट. कैलकाटा टू भुवनेश्वर टू कैलकाटा इज टू फार. अगर हम जस्ट फ्यू मिलीमीटर्स और सेंटीमीटर्स उसको मूव कर रहे हैं, तो उससे हम एक्सपेक्ट कर रहे हैं कि जो हमारा फिजिकल सिस्टम है वो चेंज नहीं होगा. मैंने कल एक एग्जांपल दिया था कि मान लो हम रिफ्रैक्टिव इंडेक्स मेजरमेंट बाय यूजिंग ए प्रिज्म ये एक्सपेरिमेंट कर रहे हैं. तो वो अगर हम भुवनेश्वर में कर रहे हैं और भुवनेश्वर से मान लो 1 किलोमीटर दूर या 2 किलोमीटर दूर कर रहे हैं, द रिजल्ट आउटकम ऑफ द रिजल्ट शुड नॉट बी चेंजिंग, राइट? तो ओवर ट्रांसलेशन अगर थोड़ा ट्रांसलेट किया तो वो आउटकम ऑफ द मेजरमेंट शुड नॉट चेंज. इन दैट सेंस द एक्सपेक्टेशन वैल्यू शुड नॉट चेंज. बट वो ट्रांसलेशन क्योंकि हम क्लासिकल क्वांटम मैकेनिक्स में बोल रहे हैं, तो क्वांटम मैकेनिक्स में द सिस्टम इज डिस्क्राइब्ड बाय ए वेव फंक्शन, वेव वेक्टर, राइट? तो वेव वेक्टर कैसे चेंज हो रहा है? तो देन वी सेड कि नहीं, वी एक्चुअली ऑपरेट विथ एन ऑपरेटर on the wave function psi, which will take the wave function from Bhubaneswar to, let's say, 1 kilometer away from Bhubaneswar. So then that kind of operator, वो operator कैसे दिखेगा? What will be the form of the wave operator? That operator for translation would be looking like I cap minus I epsilon p by h cross. जो हमने अभी डिस्कस किया कि इन जनरल, अगर इन जनरल होगा तो वो क्या होगा? S operator होगा, and that all S operator would be of the form I cap minus I epsilon then K cap, where K cap is called the generator. So for translation it is P, which is the generator. For rotation it is the Z component of angular momentum is the generator, and for time translation it is the Hamiltonian, which is the generator. And कंजर्वेशन के लिए हमने देखा कि अगर हम ऑयलर लैग्रेंज इक्वेशन और हैमिल्टन इक्वेशन ऑफ मोशन का आइडिया लेके क्वांटम में अप्लाई कर रहे हैं, तो वी कैन सी दैट द जनरेटर, अगर एक्सपेक्टेशन वैल्यू नहीं चेंज हो रहा है, इफ वी एक्सपेक्ट कि नहीं जो मेजरमेंट हम भुवनेश्वर में कर रहे हैं वो 1 किलोमीटर के बाद चेंज नहीं हो रहा है, देन इन दैट केस द जनरेटर जो होगा दैट हैज टू बी ए कांस्टेंट ऑफ मोशन. तो अगर ट्रांसलेशन स्पेस ट्रांसलेशन हो रहा है तो उसके लिए मोमेंटम कंजर्व होना पड़ेगा. अगर रोटेशन हो रहा है तो उसके लिए एंगुलर मोमेंटम, जेड कंपोनेंट ऑफ एंगुलर मोमेंटम हैज टू बी कंजर्व। अगर टाइम ट्रांसलेशन हो रहा है, मैं अभी एक एक्सपेरिमेंट कर रहा हूँ और 1 घंटे बाद सेम एक्सपेरिमेंट रिपीट कर रहा हूँ, देन द रिजल्ट शुड नॉट चेंज। अगर ऐसा रिजल्ट शुड नॉट चेंज मैं बोल रहा हूँ कि मैंने आज एक एक्सपेरिमेंट किया लैब में, रिफ्रैक्टिव इंडेक्स मेजर किया और कल भी आके मैं वही सेम तरीके से कुछ भी चेंज नहीं कर रहा हूँ, देन आई एक्सपेक्ट द रिजल्ट टू बी सेम। So अगर expectation value I'm comparing it to be the same, then the generator, which is the Hamiltonian, must be conserved, which is basically that means energy must be conserved. ने यही डिस्कस किया है।
Okay, thank you, sir.
Yes, anybody having any other question?
यूनिट 1 ରୁ କୋଉ ଟାଇପ ର क्वेश्चन ଆସିବ?
Generally जो क्वेश्चन गुड़ा शॉर्ट आंसर टाइप, टर्मिनल टाइप देइछि, सेगुड़ा प्रैक्टिस कले ही माने यू कैन आंसर एनी क्वेश्चंस।
जो एसक्यू जहां भी
हां एसक्यू
बुक्स
जोड़ा
रे
देछि,
देखि
हां एसक्यू जोड़ा देछि यू मस्ट सॉल्व इट। हां आ जोड़ा टर्मिनल क्वेश्चंस लास्ट को देछि, तार आंसर भी देछि। सो मते लागु छै जदि जने पूरा बसी के ताको सॉल्व करिवो पढिवो, then you will get everything. You can solve any questions from that section. It will not be a problem.
थैंक यू सर।
Sir, one request. This is not a question actually.
Yeah.
We have WhatsApp group, officials, okay, where the only the professors are the admin and few others.
Okay.
So I'll request to join us, so that if you wish that some good notes to be provided to the community, then you can benefit it. And there will be no exchanges, because on normal just chit chatting kind of WhatsApp, this is not like that. It is
Okay.
exclusively for resource repository kind of thing. So
Okay.
we have already Gauri Shankar ji in the group, and I request if you kindly give your number, then I can add, and with the community will be benefited out of that.
Yeah, sure. Maybe you can note down, or I can send my details to Gauri, so Gauri can add me.
Okay, that would be fine, sir. He is there. Then he can add you yourself, and will be benefited. Thank you, sir.
Yeah. By any chance, Gauri present in the lectures? No, I think so.
Yesterday he was present. Today
Yeah.
I don't think, sir.
Okay. Yeah. Well, I can send. You can tell Gauri. I will send him my details, so he can add. That's not an issue. But for reading purpose, I think I would not suggest that there will be vast number of books available, but I would suggest stick to the material provided by IGNOU. It's a very well written, concise material actually.
Yes, sir.
And for extra knowledge, I would suggest take the book which I mentioned yesterday, Ghatak and Loknathan and Stephen Gasirovich. The very lucid language it has been written, so you should be able to understand. And if you can solve few problems given in Ghatak and Loknathan, that will again improve your understanding actually. Yeah, but yeah, I can see that. Okay, so maybe we will start the next part, which is symmetry in quantum mechanics. Let me take a pause. That the way I discussed Unit 1, I might not be discussing everything in Unit 2 and henceforth. I purposefully wanted to discuss Unit 1 thoroughly, because that is something which we will be taking into next chapters or next units. So I would again suggest everybody that go through Unit 1 thoroughly, because that will give you a better understanding what exactly is happening in the next few chapters or next units. Uh, but later on, you probably have to work out a little bit because this is not normal class. This is kind of counseling, so we cannot really have everything covered in this limited number of classes. So I need your support as well, because then once you progress 50%, I progress 50%, then the overall progress will be 100% that way. So I would expect all of you to work out little bit on the material being provided. I guess all of you have this PDF and the hard copy of the book right now, right? If not,
We have the PDFs, sir. Thank you,
yeah,
sir.
yeah. So I think you should because it is something, if you work it out, then only you will be understanding. Otherwise, if you do not do the mathematics, then it will be little bit difficult to you know just get the concept clear, what exactly is happening. Okay. Next will be basically talking about parity and time reversal. Uh, Coming to this concept of parity. So, what is parity? So, parity is just an operator. So, it says the parity operator, when applied to a coordinate system, it transforms a right-handed system of coordinates to a left-handed system of coordinates. So, under a parity transformation, what happens? If you are in the first, so all of you can imagine, if you have let me, maybe I can try to show. I don't know if it will work or not. Yeah, so this is my right hand. Are you able to see it?
Yes, sir.
Yeah,
Yes,
so
sir.
yeah, so in my right hand, so my thumb finger is kind of z axis, and my index finger is let's say x axis, and my middle finger is y axis, if I put it like that. So, and then from a right-handed system, if I go to a left-handed one, which is again like this, so you can see it is, if one will be clockwise, another will be kind of anti-clockwise. Or if I try to see it, let's say if you have a three-dimensional Cartesian coordinate system, you have 8 octants, right? You have 8 octants. If you are going from first octant to, so diagonally opposite octant, so that is what it is doing. It is basically going from uh, uh, x, y, z, that is from the first octant, to the minus x, minus y, and minus z, the diagonally opposite octant. So this is what it does, the parity transformation. So how exactly it will affect our wave function and other operators, what is the significance, that we will be discussing. But one thing we have to keep in mind, parity operator क्या है? ये वो ऑपरेटर है जो सिस्टम को एक्स वाई जेड से माइनस एक्स माइनस वाई माइनस जेड को ले जाता है. ठीक है? So, look at the action of a special unitary operator, parity operator, which is denoted as pi cap. Pi cap. Pi cap is parity operator. So, it will take the system when pi cap operating on psi, it will take it to psi prime. So, psi prime cat is equal to pi psi. If that is the case, what we will have is the expectation value of position operators in the state psi and psi prime will have opposite sign. अगर हम पैरिटी ऑपरेटर ले रहे हैं और उसको ऑपरेट करेंगे psi के ऊपर, तो क्या होगा? x का जो एक्सपेक्टेशन वैल्यू है वो पैरिटी ऑपरेटर यूज करने से वो माइनस एक्स हो जाएगा. कैसे? psi prime x psi prime will become minus of psi x psi. So similarly for y and similarly for z. Now from equation 2.2 and 2.3, so 2.2 is this one and 2.3 is this one. If we use that, so then pi dag x pi dag x pi will basically be equal to minus x. क्यों? क्योंकि साई प्राइम क्या है? साई प्राइम है पाई साई, राइट? सो साई प्राइम ब्रैक क्या होगा? साई पाई डैग. सो दिस पार्ट, राइट? साई प्राइम यहां पे हमने लिखा है साई प्राइम इज इक्वल टू पाई साई. तो यहां पे साई प्राइम की जगह क्या लिखूंगा मैं? पाई साई. और साई प्राइम ब्रैकेट की जगह साई ब्रैकेट पाई डैग. So psi prime x psi prime will be equal to psi pi dag x pi psi. Now, for this to be equal to minus of psi x psi, so that means this psi pi dag x pi must be equal to minus x cap. So, this is the property of the parity operator. और ये हुआ तो क्या होगा? ऑल ऑफ यू थोड़ा मैथमेटिक्स करना है, कम्यूटेटर अलजेब्रा. लेट अस डू दैट. क्या मिला है हमें? पाई डैग एक्स पाई इज इक्वल टू माइनस एक्स. ठीक है? All of them are operators, of course. Then what will happen? If I multiply pi on the left, pi dag x cap pi will be equal to minus of pi x. Now pi dag will be unitary identity. So x pi is equal to minus of pi x. This implies x pi plus pi x equal to 0, or this is represented as x pi anti-commutator is equal to 0. Clear?
Yes, sir.
Yeah, which is nothing but the equation 2.5 given over here. All right. So the position operators anti-commute with parity operator. जो पोजीशन ऑपरेटर है वो पैरिटी ऑपरेटर के साथ एंटी कम्यूटेशन होता है. ठीक है? We next look at the action of parity operator on the position eigen k. पहले तो हमने ऑपरेटर के ऊपर देख लिया, पोजीशन ऑपरेटर के ऊपर. पोजीशन वेक्टर जो आइगन वेक्टर है, आइगन केट है, उसके ऊपर क्या चेंजेस हो रहे हैं. सो एक्स कैप पाई एक्स विल बी इक्वल टू माइनस पाई एक्स कैप एक्स वेक्टर. यही तो होता है, नहीं? एंटी कम्यूटेटर है ना. ये इक्वेशन कैसा आया, समझ में आया नहीं आया? We just discussed, right?
Once more, sir, please.
X pi will be equal to minus pi x, right? From this one, 2.5a. X pi plus pi x is equal to 0, right? So, x pi will be equal to minus pi x, right?
Yes, sir.
So, that's what we are writing. X pi operating on x cat will be equal to minus pi x operating on x, right?
Yes.
So this implies x pi x will be equal to minus of x pi x, right? Isn't it?
Sir.
And pi operating on x will basically take it to what? Pi operating on x will basically take it to minus x.
Minus.
Minus x. So this is again telling us, in the beginning we said, but from mathematics also we find that pi operating on the x cat or the state vector x, pi operating on the state vector x will take it to minus x state vector. Okay, but here we are actually not considering an arbitrary phase factor. If we have any arbitrary phase factor e to the power I phi, that will also work, because if we take the DAG, it will be e to the power minus I phi, and pi DAG will again be unity. So we can always have an phase factor e to the power I phi. So pi, but with the condition that pi square must be equal to identity. Pi square must be equal to identity. So these are the properties. These are the properties of the parity operator. क्या करेगा अगर if we are taking operating with any other operator, position operator, so that will be the condition pi dash x pi must be equal to minus x. That is condition 1. Second, that x and pi must anti-commute. Must anti-commute. That means x pi anti-commutator bracket must be equal to 0. If it is operating on a state vector, so pi operating on x cat will be equal to minus x cat. And with the property that not only pi cap, any other operator with a fetch e to the power I phi will also be doing the same work. And pi square, so pi operating on pi again, that is pi square, will be equal to identity. It is same like if you go from x y z to minus x minus y minus z, and again I operate the parity operator, then it will go from minus x minus y minus z to again minus of minus x minus of minus y minus of minus z, which is x y z. So you will basically come back to the original, which is basically identity. And parity operator is also Hermitian. Is also Hermitian. Is it clear up to this point?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Okay. So you can try solving these two small questions. Small answer questions. The pi square, we are claiming that pi square is equal to identity. So what is pi? Can we get what will be pi square? Pi square. How to get pi square is equal to identity? So and of course, if it is pi square is equal to identity, then its eigenvalues of the parity operator will be plus or minus 1. Plus or minus 1. Okay. All right. Transformation operator. If we are transforming under parity, so अगर हमने देखा कि अगर पोजीशन है तो वो क्या हो रहा है दैट x is going to minus x, ठीक है, y going to minus y, z going to minus z. So similarly, if we are having any other operator, let's say momentum is equal to mass times velocity, dr by dt. If your position is mass is not changing, if position is going from plus x plus y, no, sorry, x y z to minus x minus y minus z, then your velocity will also be moving in the negative direction. So p basically will become minus p. P will basically become minus p. So if I recall my translation operator t, t is equal to I cap minus I epsilon x px by h cross. Right? Now what will happen if I operate parity? Parity operate किया तो क्या होगा? So p will become minus p. Py will become minus py, px will become minus px, and pz will become minus pz. So that is nothing but, so the system translate इस directions में हुआ है और parity डाला तो वो फिर से it will go to in the opposite direction, space inversion हो जाएगा, है ना? So that is why, so transformation, so t of and pi t and pi किया तो वो basically that will be equal to pi t with a minus ex. Let us try to physically क्या हो रहा है वो समझने की कोशिश करते हैं. T का काम क्या है? What is the work of T? T will take the system from x to x plus epsilon x. ठीक है? और माइनस T of minus epsilon x का क्या काम होगा? मतलब that will go from x to x minus epsilon x. And pi operator का काम क्या है? That will take from x y z to minus x minus y minus z. So if you think कि पहले pi ऑपरेट किया तो वो कहाँ चला जाएगा? Let me do little bit of math here. If I'm operating pi, so then the system goes operating on pi, then it will go from x, y, z to minus x, minus y, minus z, right? और उसके बाद मैंने t ऑपरेट किया नेक्स्ट वन, तो क्या होगा? सो माइनस एक्स प्लस एप्सिलॉन एक्स और एप्सिलॉन माइनस वाई माइनस जेड, राइट? यही हो रहा है ना. और अगर हम पहले t ऑफ माइनस, दिस इज द फर्स्ट केस, सेकेंड केस में अगर हम पहले, सो दिस इज t ऑफ एप्सिलॉन कर रहे हैं, t ऑफ माइनस एप्सिलॉन पहले किया तो क्या होगा? व्हाट विल इट बी? This will be going from xyz, from xyz it will go to what? X minus epsilon y z, right? और उसके बाद मैंने पाई ऑपरेट किया तो क्या होगा? This one will become minus, so minus of x minus epsilon minus y minus z minus z. So this is nothing but minus x plus epsilon minus y minus z, right? So this one and this one are becoming same. So अगर मैं इसको summarize करूं, if I try to summarize it, so t pi will be equal to, so पहले pi ऑपरेट किया फिर t ऑपरेट किया from left, और this will be equal to pi t minus epsilon. ये पहला एप्सिलॉन था. Is it clear?
Yes, sir.
2.10 कैसे आया?
Yes, sir.
Yeah. Okay. So if we substitute again, so if we take this equation and substitute the form of t is equal to I cap minus I epsilon x px by h cross, and t of minus epsilon x will basically become epsilon x की जगह minus epsilon लिखना है, so I cap plus I epsilon x px by h cross. And if we work it out, we'll see identity. So pi will cancel. So finally, what we will get is px pi plus pi px is equal to 0, or px pi anti-commutator will become equal to 0. So px pi anti-commutator will be equal to 0. That means px pi will be equal to minus of pi px. Okay? So these are the conditions of the parity operator. So parity will not commute with px. Parity will not commute with it. Anti-commute will anti-commute with py. It will anti-commute with pz. एंड स्टेट वेक्टर के ऊपर लिया तो क्या होगा? सिमिलर टू अगर जैसे हमने x के साथ किया था, सो अगर पैरिटी ऑपरेटिंग ऑन मोमेंटम स्पेस वेक्टर px, इट विल टेक इट टू minus of px, and expectation value will become just negative of the expectation value which we get in the original state. Clear up to this point? So parity
sir.
operator
Yes, sir.
पोजीशन ऑपरेटर के साथ या मोमेंटम ऑपरेटर के लीनियर मोमेंटम ऑपरेटर के साथ कम्यूट नहीं करता है. ठीक है, तो क्या नहीं होगा, इससे पहले हमने डिस्कस किया था, अगर कम्यूट नहीं करता है तो क्या होगा, इट विल नॉट बी कंजर्व ऑल द टाइम, राइट. कम्यूटेटर जीरो होना है ना. देख जनरेटर, अगर जनरेटर है और कोई ऑपरेटर हम ले रहे हैं, इससे पहले कंजर्वेशन प्रिंसिपल में हमने बताया कि अगर कोई सिमेट्री ऑपरेशन एस ले रहे हैं और एस का फॉर्म क्या है, आई कैप माइनस आई एप्सिलॉन के कैप, वेयर के कैप इज द जनरेटर. अगर के कैप क्या हो रहा है, कम्यूट कर रहा है, तभी जाके वो क्या होगा, कंजर्व होगा, राइट. सो विल सी. So we expect there are systems where parity will be conserved, but there will be few cases where it will not be conserved. Parity will not be conserved. कुछ न्यूक्लियर डीके प्रोसेस है जिस प्रोसेस में parity will not be conserved. So position operator and momentum operators anti-commute, they do not commute. But what about the angular momentum operator? So L is equal to R cross P, right? L angular momentum vector, L is equal to, ये classical mechanics में पढ़ाया गया है ना. L is equal to R cross P, right? So from that, if you take the cross product, then you can find the z component of L, which is Lz, will be equal to y pz minus z py. Is this part clear to you? This is from classical mechanics. Angular momentum को हम R cross P लिख सकते हैं ना, right? You can check maybe your classical mechanics. I think this is
Yes, sir.
basics again from maybe in BSc also you might have studied. L is equal to R cross P.
Yes, sir.
Yeah. So P is, if you take the cross product, normal cross product rules, I cap, J cap, K cap, X, Y, Z, and P, X, P, Y, P, Z. So then from the determinant, you can find out what is the Z component. So the Z component would be Y, P, Z minus Z, P, Y. Okay. But अगर हम पैरिटी ऑपरेट कर रहे हैं, वी आर ऑपरेटिंग पैरिटी, तो क्या होता है, x बिकम माइनस एक्स, y बिकम माइनस वाई, z बिकम्स माइनस z, px बिकम्स माइनस px, py बिकम्स माइनस py, pz बिकम्स माइनस pz. तो यहाँ पे क्या होगा, अगर इसके ऊपर पैरिटी ऑपरेट किया तो y will become minus y, pz will become minus pz, so minus or minus will become plus, right? So similarly, z will become minus z, py will become minus py. So minus or minus will become plus. So your Lz will not change. Lz will not become minus Lz. Okay. Lz will not become minus Lz. So that is why when we operate parity on the angular momentum, here you can see here equation 2.16 A. So there you can clearly see that when we operate parity operator, the angular momentum actually does not change. So that's why angular momentum will commute. Angular momentum will commute with pi. So it is not anti-commutator, it is commutator. So if pi dag Lz pi is equal to Lz, so then Lz pi commutator will be equal to 0. This is simple commutator algebra. Is this part clear? You can check and ask, that it's fine. So position and momentum do not commute, but angular momentum commute with parity operator. Clear?
Yes, sir.
Yeah. So similarly, we can prove that if we have total angular momentum, which is basically spin angular momentum plus orbital angular momentum, L is the orbital angular momentum and S is the spin angular momentum, which will give rise to the total angular momentum. Then the total angular momentum will also commute with the parity operator pi. And the rotation parity, if we want to represent it by a matrix, this will just be uh, of this form. So you can see if we write x prime y prime z prime will be equal to, so minus 1 0 0 0 minus 1 0 0 0 minus 1, so x y z. So this will basically transform minus 1 into x minus x 0 0, then x into 0 0 minus 1 into y minus y. So this will basically x prime y prime z prime will give rise to minus x minus y minus z. So this is the form of uh, parity operator. So if you just use this form, can somebody multiply this minus 1 0 0 0 minus 1 0 and 0 0 minus 1 into the same matrix? Can you quickly work it out right now? Anybody?
Yes.
Yeah. Just matrix multiplication, right? And see what exactly you are getting.
Yes, sir.
Yeah. So what I'm asking, let me make it clear the question. So we have minus 1 0 0 0 minus 1 0 0 0 minus 1 into again
-1.
0 0 and 0 minus 1 0 0 0 minus 1. So if you multiply, what exactly you are getting? It is 3 by 3 matrix. So what exactly you are getting? A matrix multiplication I'm asking. I'm not asking determinant. I'm asking matrix multiplication. So what exactly you are getting?
1.
So you are getting, are you getting identity matrix? Should be getting identity matrix, right? 0 1
Yes, sir.
0 0 1,
Yes, sir. Yes, sir.
right?
Yes, sir.
So pi into
And
pi,
the final value is 1.
pi into pi is equal to identity, or pi square is equal to identity, right?
Yes, sir.
So RP is an element of the group O3, and though not of, because the determinant is -1 in this case, so it is not SO3 group. So you can discuss a little bit more on this during your group theory discussion in mathematical physics, where it will be more clear, because that is what kind of matrix you have and whether it will be O3 or SO3, that you can check. Like we, as I said, orbital angular momentum, we can also have total angular momentum. So for total angular momentum, Rz is the uh, operator for total angular z component total angular momentum. So in that case, it will be I cap minus I phi z, which is the total rotation about z axis, jz by h cross. If we have that, so then we can simply write pi rz pi. If we evaluate, so then pi jz will be equal to jz pi. So in that case, jz pi commutator will be equal to 0. And same for spin angular momentum. So angular momentum, whether it is orbital angular momentum or spin angular momentum or total angular momentum, so the x component, y component, and z components, they will commute with parity. So here is the formula that you might have to remember. I would suggest you to keep it in mind. So for position operator, this is the property of the parity operator. So many times in subsequent units or courses, when you heard the word parity, so these things would come to your mind. Okay, what is parity? Parity operator, what it does. So pi dag x pi, it will be minus x. Pi dag px pi will be equal to minus px. But pi dag lx pi will be equal to lx. And pi dag jx pi will be equal to jx. Similar for angular momentum. For angular momentum, pi dag sx pi will be equal to sx. So x and p are called odd under parity transformation because they become minus. So parity ऑपरेट किया तो वो माइनस हो रहे हैं और LX, JX and SX. So orbital angular x component of orbital angular momentum, total angular momentum and spin angular momentum, they are even. So they are not changing their sign. So they are even under parity transformation. Is it clear?
Yes.
All right. You can try solving these questions. What happens? So how following operators transform under parity? So you can say, so Lx by commutator is equal to 0. If this has already been done, actually, Lx pi is equal to Jx pi. Here actually Lx pi is equal to 0. So this one asking same question there. Actually. LZ के लिए किया है तो Lx के लिए पूछ रहे हैं. But these small questions you should work it out. So then only you will actually get familiarized with the mathematics. Transformation of the wave function. Wave function कैसे transform होगा? So this is the form of identity matrix that we discussed yesterday as well. Right? All of you remember this one. X cat x bra dx integration minus infinity to infinity is equal to identity, right? And what we are using here is psi prime is equal to pi psi. The wave vector changed to psi prime when we operate pi on psi. So there's a pi psi. If we try to look at the mathematics over here, pi psi, I can simply write pi into identity operating on psi. That is fine because identity doesn't change anything. Clear? From here to here it is clear. Pi psi, I can write pi into identity of psi. Identity does not change psi, so I can write pi psi. And I cap identity matrix, that I can write integration from minus infinity to infinity, then x cat x bra operating on psi dx. So I'm from this step to this step, I'm using this definition. So identity की जगह ये लिख रहा हूँ. So क्या हो जाएगा फिर? X cat x bra then operating on psi into dx. Okay. So that will be equal to pi operating on x, then x psi dx, So what is pi operating on x? It will go to minus x state that we have already discussed. Right? It will go to minus x state. So pi psi will now become minus x psi dx from minus infinity to infinity. Now if we make change in variable, minus x को हम x प्राइम कहेंगे, minus x to x प्राइम, तो क्या हो जाएगा? Minus x will become x prime, x will become minus x prime, psi or dx will become minus dx prime. Variable will change, minus infinity will become infinity will become minus infinity. So it will. So we are coming from 2.221a to 2.22b, where pi psi will be equal to minus from infinity to minus infinity x prime cat minus x prime bra psi cat dx prime. Since these primes are basically what? Dummy variables. So I can, instead of, and also this one, minus of infinity to minus infinity will become minus infinity to infinity. So in that case, I can simply write, it will become x, x prime minus x prime psi dx prime. So x pi psi. If we try to evaluate x pi psi, so then minus into infinity x prime minus x prime psi and dx prime, which is basically equal to minus the psi of minus x, psi of minus x. So x psi will be equal to psi x and x pi psi will be equal to psi of minus x. X का काम क्या है? X will give the position. X operating on psi will give the position. और उसके बाद हमने parity operate किया तो वो wave vector will become psi of minus x. So under parity transformation, psi of x will transform to psi of minus x. Okay. All these mathematics you have to, I can understand a little bit that just by reading or looking at it, it will not work that much. All of you, I would suggest to use pen and paper to just try to practice it, so that once you do the mathematics, it will be clear. At any step you are not able to understand, you can ask me. That is fine. Each and every almost all steps are written in the material, but the idea is what is parity operator and what it does to the different operators we have, like position, momentum, angular momentum, all, and what the parity operator does to the state vector or the wave function. The wave function goes from psi of x to psi of minus x. Position and momentum, they become x becomes minus x, p becomes minus p, whereas LZ, LZ, LX, LY, or ZX, ZY, ZZ, JZ, or spin, which is SX, SY, SZ, they do not change under parity operation. The eigenvalue of parity operators are plus or minus 1. Identity, as you have seen, pi square is equal to identity, so the eigenvalue square has to be 1. So plus or minus 1 would be the solution then. So even for even parity, psi of minus x will be equal to psi pi x, and for odd parity, जो भी operator जो भी वेब वेक्टर के केस में अगर वो पैरिटी ऑपरेटर का आइगन वेक्टर है, so then it will be psi of minus x will become psi x if it is even parity. For example, jx, jlx, sx उसके लिए, और odd parity, so psi pi x minus x will be equal to minus of psi pi x for odd parity for case of position and momentum. Is it clear up to this point?
Yes, sir.
All right. So next is parity as a symmetry operation. क्या होता है symmetry के लिए? For physical system to be invariant, this is very important. For a physical system to be invariant under a parity transformation, अगर parity transformation में physical system has to be invariant, the Hamiltonian of the system must satisfy the following condition. The Hamiltonian of the system must satisfy this condition. Pi deck h pi must be equal to h, or h pi commutator must be equal to 0. It is referring 1.81. Let us go back to 1.81. That is what I was telling in the beginning. Yeah, JZH or RZH must be equal to 0, which was coming basically from this discussion about our constant of motion, that this must be equal to 0. The commutator must be equal to 0. So that is what we also uh, come, have to use it here, that for physical system to be invariant under parity transformation, the Hamiltonian of the system must satisfy this condition, that Hamiltonian and parity commutator must be equal to 0. It is almost all the time 0, except a few cases. One example is this one. Let us look at this example. For a simple harmonic, one-dimensional simple harmonic oscillator, the Hamiltonian is given by kinetic energy plus potential energy, right? H Hamiltonian is given as px square by 2m, which is kinetic energy, plus half m omega square x square, right? All of you following this one?
Yes, sir.
Yeah. So then what will be pi dag h pi? So pi dag h pi. So I will just write the expression for h, and then if we kind of separate. So pi dag p square pi. So pi dag p square pi plus half m omega square pi dag x square pi, right? This way. What is pi dag p square pi? So p square will be px into px, right? Px into px. So pi dag px px pi. All right. Now we introduce, so pi dag pi dag is identity. Pi dag is identity that we have already discussed in the beginning. So I just introduce one identity matrix in between. क्या था? Pi dag p square pi निकालना था. So I can write p square into this px into px. फिर px और px के बीच में, in the middle, I am introducing one identity which is pi dag. Okay. So what it becomes? It becomes pi dag px pi, pi dag px pi. But हमें पहले से पता है from our this one, pi dag px pi क्या होता है? Minus px, right? Momentum operator के लिए pi dag px pi minus px होता है. So if we come over here, so pi dag px pi will become minus px, pi dag px pi will become minus px, so it will be px square. Similarly, you can prove that pi dag x square pi will also become equal to x square. So that means pi dag h pi जो हमने यहाँ से निकालना था, pi dag h pi will become what? So pi dag p square pi will become px square, and pi dag x square pi will become x square. So it will be p square by 2m plus half m omega square x square, p square by 2m plus half m omega square x square, which is h again. So pi dag h pi is equal to h. That means what? Commutes, right? Commutes. So that is what it was telling you, that pi dag h pi is equal to h. That means the system is invariant under parity. So for a simple harmonic oscillator, it is invariant under parity. Clear? कैसे हो रहा है? For simple harmonic oscillator, you can check, or a question can be asked whether the Hamiltonian for one-dimensional simple harmonic oscillator is parity invariant or not. Is this clear to you, all of you?
Yes.
All right. So similarly, we can also have a parity for a spin system. So spin angular momentum, and also it will be symmetric. But I'll come back to the case non-conservation of parity. So this is the beta decay of C60 nucleus, where they found that parity is not conserved in this kind of beta decay process. Yeah. Any question on parity?
Sir, other than the derivative, what more kind of questions can we expect in the exam, sir?
Well, short answer type questions will be basically based on maybe the properties of different operators and what happens, like parity operator का properties के ऊपर हो सकता है, या parity operator हम different operator के ऊपर operate करने से क्या हो रहा है, उस type के questions you can expect.
न्यूमेरिकल भी आ सकते हैं क्या?
Well, these are numericals, right?
but derivative kind of thing.
Yeah, short answer type. जैसे I'll come to this torment questions. Let's.
इससे सोचिए कि आप जो 2 दिन पढ़ाए हम लोग को, तो अगर सोचिए कि यू कुड हैव बीन द क्वेश्चन सेट, आप किस तरह का क्वेश्चन करते?
तो शॉर्ट आंसर टाइप जो भी क्वेश्चन है उसी तरीके का ही क्वेश्चन करता है.
अच्छा,
बहुत बड़े बड़े क्वेश्चन.
टॉर्मेंट कॉस्टिंग में जो भी दिया गया है वैसे वाला क्वेश्चन काफी है क्या सर?
हाँ, मतलब
क्वेश्चन
जो प्रैक्टिस क्वेश्चंस दिया गया है, if you solve those kind of questions, and for extra, as I said, for extra, if you want to solve few more questions, then we will घटक लोकनाथन और गैसरोविच से देख सकते हैं. बट इसमें जितने भी प्रॉब्लम सॉल्व किया है, ठीक है ना, that will be like the parity of nth SHO eigenstate is -1. ये जितने भी 10 प्रॉब्लम दिए गए हैं, you can see these are simple problems, right? ये जैसे first one was is that self assessment. Pi square is identity, जो पहले दिया गया था self assessment question. So these kind of questions actually, these are not really tough questions, I would think. अगर आप जो भी मटेरियल है, जो भी डेरिवेशंस है, उसको एक बार दो बार अपने से कर रहे हैं, you are doing on your own the derivation, then this kind of questions will be super easy. This will not be an issue. ये ऐसे पढ़ने से बहुत ज्यादा डिफिकल्ट लगेगा, ठीक है. माय सजेशन इज, जो भी इसमें बताया गया है, जो भी मैं पढ़ाया हूँ यहाँ पे, उसको आप थोड़ा प्रैक्टिस कीजिए इन द सेंस मस्ट अंडरस्टैंड कि क्या हो रहा है, इस स्टेप में क्या हो रहा है, इस स्टेप में क्या हो रहा है. एंड जैसे मैंने कल बोला था, यानी सी हम ऐसा नहीं है कि हर चीज हर टाइम याद रहेगा, बट अगर कोई चीज याद नहीं आ रहा है या तो इमीडिएटली उसको उस रेफरेंस से देख लेना है. मैथमेटिकल फिजिक्स का कोई, जैसे मैंने बोला कि अनफेस्ट थ्योरम याद नहीं आ रहा है, सो इमीडिएटली गो टू द क्वांटम वन पार्ट और द बेसिक मैथमेटिक्स पार्ट और देन चेक व्हाट इज अनफेस्ट थ्योरम, क्या क्या था उसमें. सो देन इट विल काइंड ऑफ रिफ्रेश योर अंडरस्टैंडिंग ऑफ अनफेस्ट थ्योरम एंड दैट विल हेल्प यू इन अंडरस्टैंडिंग दिस पार्ट. बट अगर ऐसे नहीं करते हैं तो फिर वो ऐसा रहेगा कि पता नहीं वो अनफेस्ट थ्योरम क्या है ना. Yeah, I'll possibly have to stop it here. If you have any question, you can simply ask me on the part we have discussed. For time reversal, I think I would suggest you to go through it. Maybe next class I will quickly explain that, and then I'll move over to addition of angular momentums. या बट जो भी प्रॉब्लम्स दिया गया है इसमें 7-8 प्रॉब्लम्स हैं, है ना, उसको सॉल्व कीजिए. तो इजी प्रॉब्लम्स है, कुछ भी उसमें डिफिकल्टी नहीं है फॉर दिस काइंड ऑफ वंस. फन है एक्चुअली, जैसे एक प्रॉब्लम सॉल्व किया तो उसको सिमिलर तरीके से ही हो जाएगा ये. How many of you have actually the printed copy of the this PDF? I would suggest all of you actually to have a printed copy or the printed book if you have already received. because since a lot of mathematics is involved in this one, so it is better to have a printed version and work it out.
I have my printed, sir.
Yeah, so I mean that is my personal opinion. Of course, if somebody is comfortable in on laptop or computer or mobile, that is fine. But idea is basically
Yes, sir, it is difficult to grab from scrolling and all.
yeah. So that's why I'm telling that you must write it on your own on your notebook. क्योंकि आप लोग अगर अपने नोटबुक में उसको नहीं लिखेंगे तो वो समझ में नहीं आएगा because bit of mathematics is involved in this one. तो कौन से स्टेप में क्या हो रहा है और कहाँ से वो मतलब 2-3 जगह ऐसे हो सकता है बट अगर कहीं पे भी आपको लग रहा है कि नहीं वो स्किप हुआ है स्टेप सो यू कैन आस्क मी कि ये स्टेप से ये स्टेप कैसे आया that explain but my suggestion is you have to work out on your own otherwise वो समझ में नहीं आएगा it will look simpler. It will look simpler when you look at the PDF, but when you work it out, it will be difficult. So,
He said we have benefited much through yesterday and today's class, and we look forward to further patronage from you.
yeah,
I have invited you in the group. At your convenience, please join us. Okay.
okay.
Thank you, sir. I texted Gauri Shankar sir, and he has kindly provided your number. So I have just invited you in the group. Okay.
Okay.
And if you have anything further to add for the community, please do sir, help us.
Yeah.
Yes,
That,
sir.
that I can do. I have joined already. So, that is fine. Any other question? Anybody? दूसरा किताब कोई खरीदा है नहीं इसी से पढ़ रहे हैं
नहीं सर इसी से तो पढ़ रहे हैं सर थोड़ा
ओके ठीक है ऐसा नहीं है कि ये जो मटेरियल है आई मीन आई थिंक इट इज वेल रिटन इन अ वेरी कंसाइज फॉर्मेट बहुत छोटे फॉर्मेट में सारे इंफॉर्मेशन देके लिखा गया है बट कोई अगर इंटरेस्टेड है to solve few more problems then I still suggest go through Ghatak and Loknath.
सर एग्जाम में तो कोई स्टेप स्किप नहीं कर सकते सर मतलब इसमें जैसा दिया गया है वैसा तो नहीं लिख सकते
Yeah, that is a very difficult question to answer. कि एग्जाम में कैसे लिखना है ना? Basically, yeah, it all depends on the evaluator. मैं अपने बात बोल सकता हूँ कि मैं जब कोई भी आंसर स्क्रिप्ट इवैल्यूएट करता हूँ तो आई एक्सपेक्ट द स्टूडेंट टू राइट फ्रॉम स्क्रैच मतलब मान लो मुझे कुछ भी पता नहीं है और उसके आंसर पढ़ के मुझे सब कुछ समझ में आना चाहिए है ना बट इट ऑल डिपेंड्स ऑन द इवैल्यूएटर आई कैन नॉट कमेंट ऑन दैट बट ऑफ कोर्स अगर बहुत बड़ा डेरिवेशन है देन वी एक्सपेक्ट कि हाँ ये छोटे-मोटे चीज उसको पता है वो ऐसे लिख देते हैं
उसी में थोड़ा सर हम लोग का प्रॉब्लम हो रहा है कभी कभी जो स्टेप जंप है ना तो कंफ्यूज हो जाते थोड़ा
नहीं मैं आई मीन दिस इज एन ओपन इनविटेशन दैट एनी इन दैट लिस्ट इन दिस पीडीएफ एंड ऑल if you have any doubt so far I have covered कि कहीं पे स्टेप्स क्या हुआ है नहीं समझ में आ रहा है तो we can discuss that is not an issue
सर एक्चुअली प्रॉब्लम नहीं होता पर अभी हमारे पास टाइम कम है इसलिए सब समझ के थोड़ा एक एक करके करने में बहुत सारा प्रॉब्लम हो रहा है अगर टाइम होता तो ये सब प्रॉब्लम नहीं होता
अगर ये एक क्लासेस अगर जुलाई अगस्त में शुरू हुआ होता तो बहुत अच्छा होता है हम लोग अभी मतलब आप सोचिए कि आपका क्लास होते होते फिर अभी 12 बजे कोई क्लास है फिर 4 बजे क्लास है तो माइंड भी तो
I can understand वो मैं पहले से फर्स्ट डे से बोला हूँ कि it looks like it is bamboozled all the information तो एकदम से सारा दे दिया गया है
और अनदर थिंग इज सर जो भी ये तो वीडियो रिकॉर्डिंग हो रहा है तो वो अगर बाद में अगर शेयर करते हैं तो जो भी किसी का छूट जा रहा है तो कर सकता है। और जो जो अवेलेबल है यूट्यूब में, उसमें अगर आप लोग सिंस यू आर इनटू द फील्ड, जो हमारे लिए बेनिफिशियरी है, बिकॉज मेनी ऑफ अस आर नौसिखिए टू बी ऑनेस्ट, तो वो थोड़ा उससे एडवांटेज करेगा, क्योंकि प्रॉब्लम होता है कि हम लोग जब फिगर आउट करने जाते हैं तो इतना मटेरियल्स है तो वो कॉन्फ्यूज हो जाते हैं कौन सा देखना है, तो पता चला जो किए हैं उसका वो एलिमेंट्री लेवल में है। तो ये एक बात होता है, तो थोड़ा अगर आप लोग का अगर, बिकॉज यू आर द विजनरी लीडर्स इन द फिजिक्स फील्ड, तो अगर वो आपको जो लगता है कि ये हमारे लिए बेनिफिशियरी है, वो अगर लिंक डाल देते तो आई थिंक दैट विल बी आल्सो बेनिफिट अस। तो देखिए,
Yeah, I think this is
एक्सपेक्टेशन फ्रॉम अस आल्सो, आई
yeah,
अंडरस्टैंड।
this is something. Yeah, it's a very good positive feedback. Yeah, we'll communicate with the study center, and if they can do all these things, because this is something really good, but that cannot be done by only one person.
बिल्कुल
Needs
सर,
some
बिल्कुल।
uh, external help to set up all the, or to moderate. I would say the moderate the all the thing, all these kind of things. So if they agree, then yeah.
They have recommended for electronics parts, but again for electronics part there is no, I mean, summary sheet or study materials to us, and
Okay.
they just recommended some few sites। तो
Okay.
तो वो अच्छा है, लेकिन फिर भी बुक्स तो बुक्स होता है, उसका भी एक अलग ये है।
Yeah, I mean वो ठीक है, मैंने एक्सटर्नल सोर्स से कुछ एक्स्ट्रा इंफॉर्मेशन मिल रहा है, वो ठीक है, बट माय सजेशन वुड बी स्टिक टू दिस मटेरियल एंड द टू बुक्स आई सजेस्टेड, एंड अगर उससे कुछ समझ में नहीं आ रहा है तो गो बैक टू द पार्ट विच इज रेफरिंग, मान लो अनप्रेस्ड थ्योरम हो गया कि कल कुछ मैट्रिक्स अलजेब्रा हो गया, कुछ और हो गया, go back to that section and read. If it is still not clear, then look for other resources. नहीं तो ऐसे होगा कि other resources इतना हम ढूंढने में बिजी हो जाएंगे, जो
बिल्कुल
मेन
बिल्कुल।
पार्ट है उसमें हम पढ़ नहीं पाएंगे, टाइम नहीं होगा, है ना। तो I think that would be my suggestion. Yeah, so if no more questions, then probably I will discuss in the next class, which is I think scheduled on Saturday, coming Saturday, same time.
Thank you।
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.